So OSNAP stands for Overturning in the Subpolar North Atlantic Program, and OSNAP is the first program that is going to directly link the formation of these deep water masses to the overturning circulation. And so what OSNAP is doing is having this observing system in the North Atlantic where the action is taking place.
So this is an area that's sort of between Canada, Greenland, Iceland and Europe. And we know that the ocean, we sort of have this broad picture of what the ocean currents are doing, and that there's northward flow of warm salty water in the surface and then a return flow of cold fresh water at depth. But we have never actually been able to measure it directly before.
There's not been a consistent set of observations taken at the same time at high frequency, so measuring the circulation on periods of days, weeks, months. In the past we've had a gappy record, we've just been measuring this branch of the circulation or that branch, but never the whole lot at the same time. So that's what we're doing.
So making measurements of these ocean currents is a huge challenge. The ocean is incredibly big, it's very wide and it's very deep. So we rely on our understanding of the physics of the ocean currents and what drives them to decide where to place instruments in the water so that we can get a measurement of how the currents are changing over time. So the North Atlantic is made up of a series of ocean basins, so the seafloor sort of rises and falls to create these basins. And we are placing instruments along the edges of the basins to capture the currents as they flow around the ocean seafloor.
Often we're just limited to using computer models, which to try and understand the processes involved in this, the physical processes. So this new observational program, it's an international program with 7 different countries involved, that will be actually taking these observations at high frequency every days to weeks to months for a 5-year period at least.
Observations mean in practice measuring the temperature within the water column, the amount of salt. Those two together affect the density of the ocean, and we have to measure the strength of the currents, and by measuring that at different latitudes we can work out how properties in the ocean such as the heat are transported from one latitude to another latitude.
If we have better knowledge of the different components of the AMOC at all these areas, in all those regions, we will be able to better understand what is important or what is not.
The important issue is how these ocean currents change over time and the impact that that has on our climate, on our weather, on economically important things like fisheries as well.
We now have this first mooring array since 2014 within OSNAP, and already from 1 year of mooring results, so that means continuous measurements throughout the whole year, we already see that there's a really strong variability in the currents. Up to now we thought that the AMOC is maybe a constant number, like so much water is flowing north and so much is flowing south. So it's definitely not as simple as we first thought.
I think OSNAP is a fantastic opportunity to really unravel what is happening in the high latitudes of the North Atlantic in terms of the overturning.
The combination of instruments and expertise from so many different countries just is evidence that everyone thinks it's a problem and that it's important, and that's really exciting.